Hey all, this is Math 116, section 0.4, radicals and rational exponents. So same properties of exponents as 0.3, but now we get a few new ones because they're going to be fractions. So this first one is reminding you that x to the 1/2 is the same thing as root x. And in general, x to the 1 over n is going to equal the nth root of x. So when it's a 1/2, we don't usually put the 2 here, but 1/3 is the same thing as cube root and so on. X to the m over n, and I know that's written really small, so I'll write a little bigger here, is power over root is a good way to think of it. The top number is the power, bottom number is the root. And then those same properties of exponents. And then even and odd, so negative under a radical does not produce a solution for even roots. For odd roots, you can totally have a negative under the radical. So let me show you that with some context. Okay, so for this first one, we got the fifth root of negative 32 cubed. So the negative isn't in parentheses, so we're going to go negative 32, negative 32, negative 32 in the calculator, and it's going to make the fifth root of negative 32,768. And then we can go the fifth root of that on the calculator, and that's going to come out negative 8. And let me show you how to do that on the calculator. So, we can actually put this all in at once and kind of skip this step. But if you wanted to go negative 32 raised to the third, that's how you get that value I got there. And actually, I'll show you a cool button here because this is a really super good one to know, so don't fast forward. And then for me, it's the second function of my power. So I would put in the 5 first for the cube root, right, or the fifth root, and then second, and then the little root with an x on it. And then instead of having to retype that number, I can go second function answer. It copies the answer from the last screen. You will love this as this course goes on. And then hit equals, and there's negative 8. B, so this would be negative 81 3 times, which would make a negative number. So we'd have a fourth root of some negative value, and that's what we can't have because there's nothing I can multiply 4 times and make it come up negative. So this is a not real. 125 to the negative 2/3, so that's the same as 1 over 125 to the positive 2/3. So this is negative in the exponent. And then this is the root, the cube, so cube root of 125 is 5, and then squared would be 120, or would be 1 over 25. You can also put this straight into a calculator. So this would look like 1 divided by 125 raised to, and then really important to open a parenthesis there because we're going to put a fraction. So 2 divided by 3 and then close the parenthesis. And then that's going to give me this decimal, which I think the computer probably wants the fraction version. It might take the decimal, I'm not sure. But we can go second function, and on this calculator, it's f to d right there. And then it will tell me it's 1 over 25, and your calculator also has a similar button. And this next one, so this would be like a negative 1 times 125 to the 2/3. So that's like negative times cube root 125 squared. So for me, I'd probably think cube root of 125 makes 5 squared, and then that's going to be negative 25. But again, we could type it straight in here, and it would tell us that. Number 2 is rewrite the radical of fractional exponent, be approximate with calculator 4 decimals. Okay, so if I wanted to rewrite this as a fractional exponent, remember the nth root is 1 over n, so this is the same thing as 5.79 raised to the 1/11th. And so I can either put that in the calculator as the root or the fractional exponent. So if I throw it in as the root, oops, I need to put 11 first, and then the little root symbol, and 5.79. And I get that. I could do the same thing, raising it to the 1/11th. I just have to make sure I put parentheses around that. So to 4 decimal places, that's 1.173, and it was 0.9, so that will be 1. So this next one is replace the radical of fractional exponent. So remember, it goes x to the power over root. So this would be x to the power is 9 and the root is 4, so x to the 9/4. And we don't want to turn that into like 2 1/4 or something crazy. 9/4 is perfect. Next one's going the opposite way, right in radical form. So 7 is our root, so it's going to be the 7th root of x cubed. These next few are using the properties from 0.3. So remember, when we were dividing, we would subtract. So this will be x to the 4/5 minus 2/7. And then we just have to remember how to do fractions. So when we're adding and subtracting, we need a common denominator. So that'll be 35 in this case. So this side gets a 5/5. This side gets a 7/7. And that'll be x to the 28/35 minus 10/35, which makes x to the 18/35. That'd be it. This one is multiplying, so we'd be adding. So -3 plus 5/4. So this one needs 4s to get to a common denominator. So that'll be x to the -12/4 plus 5/4. So that is x to the -7/4. And we don't like negative exponents, so we rewrite it 1 over x to the 7/4. 7 through 11 are the ones that have you try in class. So find the powers and roots, and then if it's not real, write not real. So again, this is going to be the 4th root of a negative number, so that is not real. If it was a 5th root or an odd root, it would be fine, but because it's an even root, can't have it. 4 to the -3/2, so we could rewrite that as 1 over 4 to the 3/2. So that means we're going square root 4, which would be 2, and then cubed, which would make 1/8. This is the same thing as, so it's to the 2/3 if you can't see that on a small screen. So I would think of it as the cube root of the fraction and then squared. And again, you can put it in a calculator. Cube root of 8 would make 2, cube root 125 would make 5, and then squared would make 4/25. Again, just if you want to see that. So go 8 divided by 125. And that all needs to be in parentheses, so the exponent works on all of it. And then same thing with the fractional exponent, it needs to be in parentheses. And then we get this answer, and then again, if we want to see that as a fraction, I can go second fraction to decimal and get the 4/25. Number 8 is rewrite with a fractional exponent. So power is 11 and the root is 6. 9 is right as a radical. So this would be the root is 7, so it'll be the 7th root of x cubed. And then these two simplifies, so x to the 2/7 plus 1/6. 7 6 of 42, so this one gets 7s and this one gets 6s. So x to the 12/42 plus 7/42 makes x to the 19/42. And number 11, we got x to the 2/5. Shoot, that was a minus. Sorry, I'm going to go back and fix that now. So now it is x to the 5/42. Sorry, it's division, so I should be subtracting there. For 11, that one should be adding, so 2/5 plus 1/3. And then 15 would be my LCD. I'll do 3's on this side. So I'll make x to the 6/15 plus 5/15, and it makes x to the 11/15. And then this is going to be simplifying roots. So a good way to look at this is, in terms of the numbers, we're looking for the biggest perfect square that divides in. So in this case, square root 49 is 7. So 7 times 7 makes 49, so root 49 is 7. So a 7 will come out. And then the easiest way to do the powers is I just think about what the index would be, which is the little number up here. So in this case, it'd be a 2. It's invisible because it's a square root. But then you just go, how many pairs are in 6? Well, 2 goes into 6 3 times. So there's 3 pairs, so 3 come out. 2 goes into 10 5 times. So there's 5 pairs, so 5 come out. We can do the same thing with a cube root. With a cube root, we need to identify what the biggest perfect cube is. So 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and we're looking for what of these would divide in. And then 5 cubed is 125, and I think that's the one that's going to go in twice. So we can think of this as the cube root of 125 times 2, x to the 10, y to the 14. So cube root of 125 would be a 5 out front, and then we leave myself some space here for x's and y's, and then I put the 2 in there so I don't forget it. And then we go 3 goes into 10 3 times, so we're looking for how many triplets there are. So there'd be 3 triplets with 1 left over. And 3 goes into 14 4 times with 2 left over. And if you want to see more of that, if you check out Math 095, this is section 8.2 on my YouTube, and I do a bunch more examples. So if that was just kind of a little reminder, but if this is new to you, you can check it out there. Here with the multiply, we can multiply the stuff underneath. So that'll make 36 x to the 4, x to the 5th. So we're adding, so that'll be x to the 9th, and y makes y squared. And now we'll simplify. So square root 36 is 6. Again, we'll think of the little 2. 2 goes into 9 4 times with, 1 left over. And 2 goes into 2 once, so I should have left myself room for a y there. And then this last one is rationalizing denominators. So 5x to the 7th w. The first thing we do is simplify everything I can out of here. So the square root of 16 would bring out a 4, and the square root of w squared would bring out a w. And then there's going to be an x left under the radical. And then the deal with this is we can't leave roots in denominators, and so what we do is called rationalizing the denominator. So with the square root, which is all we're going to look at in this class, we can just multiply it by itself, because square root x will make a plain x. And what that does is it just kind of applies the root up to the numerator and gets it out of the denominator. And then 4wx. And then last step is we have x's numerator and denominator. So I just need to 7 up and 1 down would leave me 6 up top. And then w over w would cancel. So root x, and then over 4. Okay, these next 4 I would have you guys try. So thinking of our cubes again, 27 goes in twice. So cube root of 27 would be a 3 out, and it's going to leave a 2 on the inside. 3 goes into 13 4 times with 1 left over, and 3 goes into 8 twice, so 2 y's come out with 2 left over. This one will be easier if we multiply them together first. So 27 times 3 is going to be 81. 7 and 3 on the x's, so that'll make 10 altogether, and 1 and 4 on the y's, so that'll make y to the 5th. And then square root 81 makes a 9. Again, we think of the little 2. 2 goes into 10 5 times. 2 goes into 5 twice, with a y left inside. Number 18 is rationalize the denominator. So the trick here, we can think of this as root 2, root 5. So the problem part is the root 5 because that's the part in the denominator. So again, I just multiply it by itself. So root 2 times root 5 would make root 10. And then root 5 would make root 25. So it simplifies to 5. And we cannot cancel these because this is under a radical, this is not. So if we had something out front here, we could cancel. If they're both under a radical, we can cancel. But if one is and one isn't, we can't. And then this last one, so I would do the radical first and see what's left. So 6x to the 10th w, And then square root 25 makes 5. Square root x I can't do anything with. Square root w squared I take out w, and it leaves me a root x. I will multiply top and bottom by root x, since that's the stuff under the radical. That'll give me 6x to the 10th, w root x, and then 5 x w, so x times root x makes x, and then w. And I can reduce a little bit here. So 10 up, 1 down would leave me 9 up top, square root x, and then over that 5 that's left.